Let's have a look at what happens to packets at router 1 in two different situations using this particular network. Now, host A being at 10.115/24 now would need its default gateway set to 10.1.1.1 at this point, the fast Ethernet interface on that router that is facing host A. So host A at this point wants to send packets over to host B at 30.115, sees that it's definitely on a different subnet, sends those packets to its default gateway at 10.1.1.1. And during the break, I also changed the addressing on router 1 to reflect what you're seeing here. So the routing table that we see on router 1 is this. Two different ways to look at it. Pardon that move there. Two different ways to look at that table. You can run show IP route, which will give you that code table and then a little information about something called the gateway of last resort. And then it's going to show you every route in the IP routing table. If you just want to see connected routes, show IP route connected is the way to go, because you're going to have in the future, I mean, you'll have routing tables that could take up this whole screen, maybe even a little more. And you could have 6 different kinds of routes. And if you just wanted to look at the EIGRP routes, for example, you could just do show IP route EIGRP. Here we're doing show IP route connected just to illustrate that command to you. Now let's see what would happen here, because if packets come into this router and they're destined for the 30.110/24 network, what happens? Well, the router goes to its routing table, and officially the word is parsing, although you don't hear that too often anymore. Parsing the routing table, which is a fancy way of saying it's looking in the routing table for the best match. Well, in this case, it doesn't have any match at all, best or otherwise, because 30.110 does not match either one of those two entries we have in there in any way, shape, or form. So what happens in that scenario? Well, unfortunately, the packets get dropped. They do actually come into the router, but then as the router's processing them, it says, hey, I have absolutely no idea what's going on here. I don't have an entry for 30.110, so I'm just going to drop these packets. And that obviously is not what we want. So in the real world, to be frank here, what you would do is most likely configure a dynamic routing protocol between these two routers, either RIP version 2, EIGRP, or OSPF. And then they would automatically exchange some information once they form an adjacency, or not in the case of RIP version 2, but you'll see that. But they would still talk to each other and say, here are the routes I know about. Which routes do you know about? Oh, okay, thanks for those. I'll put them in my routing table. That's really fundamentally what the routing protocols are for. But none of them run by default, so we don't have any way right now for router 2 to tell router 1, hey, I know how to get to the 30.110/24 network. So we need to do something at router 1 right now to tell router 1 perhaps, hey, if you don't have a match for a particular packet, here's where to send it. And that's what I'm going to do now with what we call a default static route. And a static route is exactly what it sounds like. It's a route that you and I, the network admins, actually create. And hopefully it goes into the routing table like we'd like it to. And that's what we're going to do here. And with the default static route, the name is a little misleading, because when we hear the word default in our business, what do we think about? Oh, well, that's what happens. That's what happens unless we change something else. That's the first thing that's going to happen. A default static route is more like a route of last resort, or maybe a gateway of last resort, as we'll see. And what it's doing, it's saying, okay, router, if you don't have any other match for these packets, if there's no other match in the routing table, then send them to this IP address, or throw them out, technical term, this particular interface. Send them out this interface, or send them to this next IP address. Let me show you the command for this, because it looks strange. It's an odd looking command. Now with IP route, the first thing we're actually putting is the destination prefix. We will write some more static routes throughout the course, but right now with the default one, that's going to be all zeros. Then the destination prefix mask, that's going to be all zeros too. So a default static route, again, is IP route, all zeros, and then all zeros again. Then we have a choice to make. And you'll see that at the very top it says forwarding router's address, and then everything else on here is an interface type. Here's the deal. If you put an IP address in this command, then you are putting the IP address of the next hop router. And in this case, if we go back to the diagram, where would we want router 1 to send those packets to? Well, we don't want them to go back out fast Ethernet 0/0. That wouldn't make any sense. What we're doing here is saying, okay, send them down to 2112, which is router 2's fast Ethernet 0/0 interface. And basically, what we're doing there is the same thing we do with the default gateway on host A. We're saying, send these packets to this address, and I hope that address knows what to do with them. We know from looking at this diagram that it will. So let's make that happen. If, though, we're going to use the IP address in a moment, but if you specify the interface, you are specifying the local router's interface, the router you're on. And I'm saying that because I know this is going to come up on your exam one way or the other. And if it came up on multiple choice, they could give you IP route 000000000 and then put, the local router's IP address, which would be incorrect. Now, this is one of those things where if I actually try to put the local IP address in, the router will not let me do it because I'm trying to put a next hop address that actually exists on this router. And I've always loved this output when it says invalid next hop address and then kind of whispers to you, hey, it's this router. So if you're putting an IP address in, you're putting the downstream router's IP address in. If you're entering an interface, you're entering the local interface and you're saying, hey, put those packets out this particular interface and let's hope a downstream router can get them. No right or wrong, but way to do that or way to make a choice. I just like to specify the IP address myself. So I'm going to say 2112, and that's it. So that's our default route. Now let's have a look at the big routing table. And a couple of changes here. First off, we have a new route, but look at next to gateway of last resort. And now it says is 2112 to network all zeros. So what we've done now is really given this router a default gateway, a gateway of last resort, saying any packets that don't match the other entry, send them to 2112. And notice the code here next to the new route down here at the bottom. And you can see there's an S and an asterisk. That unique combination is unique to a default static route because static routes are indicated only with an S. And if you have a candidate default route, which in this case is definitely the default route because it's the only candidate default we have, it's going to have an asterisk next to it. So when you see an S and an asterisk like this, you know you're dealing with a default static route. And you can see via 2112 is the entry, and that's exactly what we want. So at this point, when packets come in on router 1, this is what's going to happen. Router 1 is going to look in its routing table, and it doesn't really have a specific match for 3110 because the only routes it knows about are the connected routes. But it will then say, oh, okay, I've got a static default route. I have a gateway of last resort at 2112, so I'll send them to 2112, and then I'll let that device sort it out. And we know that since router 2 is connected to the 3110/24 network, it would have absolutely no trouble forwarding packets to 3115. So that's one use of a static route. We'll see some others, but good experience for you there. And one thing here I do want to mention, and it's good, I say it's good life advice. It's good networking career life advice. If at this point we wanted packets to go from B to A, we'd have to write another static route on router 2. Because if router 2 gets packets where the destination is 10110/24, again, router 2 wouldn't have any idea what to do with those packets, so it would drop them unless we wrote another default static route. The reason I mentioned this is when you're starting to send pings, when you're starting to check connectivity, as we'll be doing, the packets have to go from A to B, obviously, but they also have to get some replies from B to A. And don't take it for granted that just because A can communicate with B, that B can necessarily communicate with A. That's just good advice for your networking career period, because people tend to look at it. If you send a ping right now, it would go from A to B, but it wouldn't have a way back unless we put a static route on R2. But then if the ping failed, people tend to concentrate on host A and say, okay, what's the trouble here, or what's the trouble with router 1? Your pings may be getting where they're supposed to go, but there may be no path back, and always make sure there's a path back. That is the end of the DAD lecture, but coming up next, what are we going to do? I think we'll do some more switching. We'll see. But let's go ahead and move on to the next section. See you there.